Okay, question 3. You've got a concrete highway with a curve of radius 70 meters is banked at a 15-degree angle. Okay, let's start drawing this here. There's the banked curve. Always with these cars going around in a circle, I like to draw the back of the car. So there's the back of the car. And it's driving around, so we'll say that the acceleration, centripetal acceleration, is towards the left. There's this, I'm going to call theta, is 15 degrees. Car total mass, so the mass of the car equals 1400 kg. Drives around this curve at a constant speed of v equals 21 meters per second. It has rubber wheels and they do not slip. Okay, so the force of static friction is less than Fs max, I guess. No slipping. Does not slip. So we don't actually know anything about F sub s. It's going to be an unknown. What is the what is the magnitude of F sub s? So this is find. So we don't have an equation for that. We can't use the Fs max equation because it's not slipping. And it doesn't say that it's about to slip either. So we're going to have to treat it as an unknown. So let's draw a free body diagram of car. So let's look at this. We're going to have gravity acting down on it. mg. What else? I guess the normal force is acting up away from the curve. And then you've got static friction. So static friction I know is perpendicular to the normal force, so it's either going to be up the hill or down the hill. Which one do you think? I actually don't even know. So I'm going to put it down like this, F sub s, as kind of a guess. I know it has to either be up or down. We're going to assume it's down the hill, and if I get a negative value for F sub s, which I'm going to solve for, then I'm going to know it's up the hill. I've just made the wrong choice, so it'll be okay. So assume F sub s is down the hill for positive F sub s. Okay, and if it's negative, we'll know it was up the hill. Okay, so now I want to do this trusty table of x and y components and sum up my forces and look at the net force. Now, the point of this is that it's accelerating towards the left, and so the net force is towards the left here, towards the center of circular motion. So, whereas if I was doing a ramp, for example, I would normally put the y and x axes perpendicular and parallel to the surface of the ramp, and then the gravity would be on an angle. But I think with a banked curve question like this, since the net force and the acceleration is horizontal, I'm going to want to put one of my axes horizontal. I'm going to put the x-axis horizontal, so that when I do the acceleration in the y direction, it'll be 0. If I tilted my y-axis, that would be a problem, because, let's erase that, then I'd have acceleration in that y direction and in the x direction. So I want one of these accelerations to be 0 at least. So I'm going to choose my y and x axes like this. So when I do that, let's list these forces. We're going to have normal, we're going to have static friction, we're going to mg. The x component, so actually all these things have components. The easy one is going to be mg. It has 0 x component and negative mg in the plus y direction. So that was the force I could fill in. And I'm going to sum them all up to be F net. But I'm going to need some extra little triangles to help me figure out the n and the F sub s. So n goes like this. I'm going to have an n sub x and an n sub y. And I think the angle theta is in there like this, and here is n. So sine of theta is opposite n sub x over hypotenuse, which is n. So the n in the x direction is going to be positive, because I defined x towards the left, of n times sine of theta. And similarly, the y component will be n times cosine theta, where n's an unknown. And then the static friction will be down and to the left. So there's positive f sub s x and negative f sub s in the y direction. Here's f sub s. So the x direction will be f sub s, an unknown, and here's our little theta. So there's going to be a cosine, I think, of theta. You can check my trig if you want. And then the y component will be negative f sub s, our unknown, times sine of the theta. So when we sum all this up, the F net in the x direction is your centripetal force, mv squared over r. And your F net in the y direction, do you know it? It's 0, because it's not accelerating up or down. It's only accelerating just towards the left.